Hello, my name is Robert Smith and I'm with New River Community College, and today we are looking at the formal charge. We're going to be writing the formal charge for a sulfate ion and then follow that by drawing the most likely Lewis structure for ethanol using formal charges. So let's get started. First thing we're going to want to do is draw the sulfate ion as a sort of skeleton. So what is sulfate? Well, sulfate is SO4 with a 2- charge on it. That's from chapter 2. So let's just get a basis for it. We've got sulfur, and we're going to have 4 oxygens surrounding sulfur. Now, we need to figure out how many valence electrons we have. Sulfur is in group 6, so it has 6 valence electrons, as does oxygen, plus there's 2 extra, so we have 6 plus 4 times 6 plus 2. That's going to give us 32 total valence electrons that we have to account for when drawing the Lewis structure. Now, the reason why we're trying to get the Lewis structure down is because that and formal charges are directly linked. We need to have both components in order to understand what we're looking at. So let's go ahead and continue drawing this. We've got for the basis, we're going to have a direct connection that's 8 electrons total right now. And then, just like with the phosphate in the previous video, if we were to draw the rest of these, it fulfills the total number of electrons. All of them are accounted for. If you count them up, that's 32 total electrons. And it satisfies the octet for everything. So everything seems correct until you try to do the formal charges. Now, what is a formal charge? Formal charge is going to be your valence electrons minus the number of what I'll call free electrons. Not exactly free, but those are the little dots that you see around the oxygen. Each one we'll call a free electron. And then minus the number of bonds. This is not exactly an accurate description of what a formal charge is, because formal charge, you would have to say it's half the number of bonded electrons, but that's the same as the total number of bonds. This is a more simple in terms of conceptuals of how to write out formal charge, at least at this stage. If you think about it in these terms, always, if you're asked something conceptual, you might make a mistake. So this is purely for calculation purposes. All right, so if we were to draw out the formal charge or write out the formal charges for this, you'll begin to see why this is an inaccurate representation of a sulfate ion. First of all, it needs to have its 2- on it. Okay, so the first thing we're going to look at here is that we're going to have 2 cases. We're going to have the sulfur case and the oxygen case. In sulfur, in oxygen both, we start with 6 valence electrons. Sulfur doesn't have any free electrons on it, and it has 4 bonds on it. That gives us a formal charge of +2. Each of the oxygens are identical, and they all have 6 free electrons and 1 bond, which gives it a formal charge of -1. The whole concept of formal charge is in terms of determining what is the most stable structure in terms of Lewis structure, is that you want as many of the species to have as close to a 0 formal charge as possible. And this can be explained later in your book and in the notes, but for this purposes, all we're doing is writing out the formal charges. So we're going to have to redraw this sulfate ion. There's something wrong with it. Well, again, this has to do with an expanded octet because sulfur is a period 3. It can have an expanded octet. Just make sure that you're careful about that because if you end up being tempted to expand the octet for a period 2 element, you are sorely mistaken. Only period 3 and above can get an expanded octet. So keep that in mind before you get too crazy with the expanded octets. So what we're going to do is we're just going to create 2 sets of double bonds. So 2 of the oxygens are going to be double bonded to the sulfur, and 2 are going to remain single bonded. So this was our incorrect formal charge. The correct one, we're going to have oxygen, and then we're going to have oxygen prime. The oxygen is going to be our original ones, so they haven't changed. The oxygen on the left and the right have not changed, so their formal charge has not changed. But let's take a look at the oxygens above and below sulfur in this picture. Still start off with 6 valence electrons, as you always will. In fact, sulfur is going to have 6 valence electrons as well. But the number of free electrons on these oxygens now is only 4. And the number of bonds is 2. Look at that. We now have a 0 formal charge on the oxygen. So this benefits the oxygen. How does it benefit sulfur? Sulfur still has 0 free electrons, but now it has 6 bonds on it, which again gives it a formal charge of 0. This tells us that this is the correct or most accurate conformation of a sulfate ion that we have in terms of Lewis structure. You'll want to get in a habit of using these formal charges as often as possible because they're going to dictate the Lewis structures, especially for your more complicated molecules, because you simply do not want a scenario in which you have spent all this time and energy making sure you filled your octets, and then it turns out that one of the bonds should have been a double and the other one should have been a single, or something like that. You want to make sure that you're fully aware of how these structures are playing out in terms of formal charges. So our next request is to draw the most likely Lewis structure for ethanol. Ethanol is C2H6O. And you can draw that out. If you remember the propane from the previous video, you'll know that our carbons are just going to be right there. Hydrogens are very happy around. Now the real question becomes, is it that we have the oxygen attached to the carbon and then a hydrogen attached to that, or how many bonds are done to each species and in what fashion? And we're going to just start with oxygen, hydrogen. If we were to count the total number of valence electrons, we have 2 carbons at 4 apiece, 6 oxygens at 1 apiece, and oxygen, edit. We have 2 carbons at 4 apiece, 6 hydrogens at 1 apiece, and 1 oxygen at 6, which gives us 20 total electrons. Each bond is worth 2, so we got 2, 4, 6, 8, 10, 12, 14, 16 total. So we really just need 2 over here. And we can verify this through formal charges. This seems like pretty obvious when you look at it. There isn't too many other ways you can draw ethanol. But let's take a look at the formal charges. For hydrogen, has a valence of 1. Number of bonds, number of free electrons is 0. Number of bonds is 1. So it has a formal charge of 0. Carbon. Both carbons have a valence electrons of 4, has 0 free electrons, and each of them has 4 bonds. So it too has a 0. Oxygen starts with 6, has 4 free electrons and 2 bonds. Look at that. It's also 0. So this is a very happy molecule. It has everything is very organized and structured, and there are no charges to try to disrupt its structure. So this is how you can use formal charges to verify the structure of Lewis structure of molecules that you've created.